How you doing, Dr. Zane? Today we're going to be messing around with the Bernoulli's equation. But the first thing I'm going to do is show you my experiment. So here we have it set up where our water faucet flow rate is as close as we can get it to our whole flow rate. And what that does is it keeps a constant amount of water in that cup. And one other thing to note about it is 11 inches above the surface of the sink, which is our Z of 0. Okay, so now we're going to do some math. Come on. We're going to start off with the Bernoulli equation itself, which is P1 plus 1/2 rho V squared plus rho GH is equal to some constant. But in this case, it's equal to another form, the Bernoulli equation, so that we can solve for our velocity of the flow coming out the hole. Alright, so once we understand that both the atmospheres on the top of the cup and the hole are 1, we can cancel those out. And also, on the left side of our equation, we are simply focusing on the cup itself, and the right side is going to be our hole. So the left side equation has no initial velocity and puts this part of our equation to 0, whereas on the right side, we have no potential energy, and it puts that part of our equation to 0. And when we simplify down, we come out to GH equal to 1/2 V squared. Simplify further, we get V is equal to the square root of 2GH. And as I said earlier, we had our height of 11 inches, which is equal to 0.279 meters. And gravity is obviously our constant. Once we plug numbers in, solve, we get our V of 2.34 meters per second. Alright, now that we have our velocity, we're going to use that to help us prove Bernoulli's equation and solve for our flow rate. The key things we need in flow rate is going to be the volume of one of these plastic cups, which is 2 cups or 0.000473 meters cubed. And the reason we need it in volume is because our flow rate is obviously in meters cubed per second. Alright, second thing we need is the diameter of our hole, which is 0.0025 meters. And once we have all that, we want to plug it into our flow rate equation of velocity times area and equal to our flow rate. And it's going to be pi d squared over 4 for everything, and what we come out with is 0.000114 meters cubed per second. And once we have this number, and we know that we have a volume that is constant right here, we're going to take and solve for our time. And the reason we're going to do that is we're going to fill up we're going to see how fast one of those plastic cups fills up, and hopefully we're going to fill up around this time, because once we solve down, the number we already have, T is equal to approximately 41.49. Alright, time for the experiment. Alright, now we're going to actually see if this takes about 41 seconds to fill up. 3, 2, 1. Now we wait. Alright, we'll start our overflow at about 42.93 seconds, but could have been some human error, maybe some math error. We're going to call it good for me.